All right, so today we're going to work on continuing with our exponential growth and decay. We're just going to create more formulas and equations based on our formulas that we were given and learned yesterday. So let's take a look at this first example. It says Mr. Smith invested $2,500 into a savings account that earns 3% interest compounded annually. He made no additional deposits or withdrawals. Which expression can be used to determine the number of dollars in his account at the end of 4 years? So one thing that you're going to see that's different about this problem compared to all the ones that we did in the first lesson of exponential functions is I'm giving you an actual time period. So we're looking at the end of 4 years. So as a reminder, this is our exponential growth and decay formula, right? So if we have a growth, we have y equals a 1 plus r to the x. Decay, the only difference, we have a minus. As a quick review, our A, our initial value, our R is our rate, which is always percent written as a decimal, and our X is a time period. So in all the problems originally that we had in our first lesson, we didn't have any time periods. We're going to be plugging in numbers for our time periods. So we have to look at our answer choices, and if you take a look, the only thing that's different about them, they all know that it's going to be an exponential growth. They all have a plus. They all have the same initial value, which of course that's not going to change. That's given to us in the problem. We have to figure out now what is the rate and what is our time period. So we're looking at 4 years. Our 4 is going to be what we find in our exponent. So with that being said, we should be getting rid of choice 3 and choice 4. These have our 3 in our time period. Then we have to determine, well, is it going to be 0.03? 0.03, or is it 0.3? Well, as we learned in our first lesson, we always take the percent and we have to change it into a decimal. So we have 3%. That means our decimal is here. We always move it over 2 units. Filling in with the 0. So then our decimal is going to be 0.03. So with that being said, our answer choice 1 is going to be the correct answer. Let's take a look at another problem. Kathy plans to purchase a car that depreciates, which means to lose value, at a rate of 14% per year. The initial value of the cost was $21,000, which equation represents the value V of the car after 3 years. So again, we're given a time period, so we know that's going to get plugged into our exponent. Now, let's take a look. They all start off with that 21,000, but we don't see that 1 plus the rate in any of these. We only see numbers. We don't have a 1 plus anything. There's no mathematical symbol. So what that means is they actually already did the operation. So if we were to set this up, we know it's a decay. It tells us that it's losing value, so it's going down. So we would start off with our V is equal to, our initial value is that 21,000. We know it's a decay, so it's going to be 1 minus, our rate was 14%. Well, that's going to be 0.14 to our third power for years. Now, if you take a look, this is not any of our answer choices. What they did is they did that 1 minus 0.14. That's why we don't have any operations here. So we now have to say, okay, well, what is 1 minus 0.14? Well, that's going to leave me with V equals 21,000. 1 minus 0.14, if you were to put it in a calculator, you would see that you get 0.86 to the third power, which is going to give us choice 2. Couple things to notice here, they just put in the rate. They didn't have that 1 minus our rate. Here, they made it a growth. They did 1 plus 0.14, giving us 1.14. The problem here is they said multiply by 3 as opposed to putting it to the third power. All right, let's take a look at this one. It's a little bit different than the first two that we've just done. It says Milton has money invested in his stock portfolio. The value V of X of his portfolio can be modeled with the function V of X equals 30,000 times 0.78x, where X is the number of years he's made since he has made his investment. Which statement describes the rate of change of his value of his profile? So they gave us the formula already, right? They're not looking for a formula. We have to figure out, well, was it increasing or was it decreasing, right? So there's only one difference between a growth or a decay, right? So that is going to be the plus or minus. So I want us to think back to this problem here, right? They had already combined the plus or the minus when we were working on it. If it's always going to either be 1 plus, see, if it's a growth, it's 1 plus R rate. And if it's a decay, it's going to be 1 minus R rate. So if it's a growth, the number in our parentheses is going to be bigger than 1. If it's a decay, our number is going to be smaller than 1 in our parentheses because we're subtracting away from 1. Well, this number is smaller than 1. It's 0.78. So it's smaller than 1. That means it's going to be a decay. So I'm going to get rid of my increases. It's not going up. Now, the same way how in that last problem we got that 0.86, we had to do 1 minus something to get that 0.86. It wasn't 70 or 78%, which is what they want you to assume to pick. You have to do 1 minus the rate gives us that 0.78, okay? If you do some algebra, -1, we'll have negative R is equal to negative 0.22. The two negatives then becomes that our rate is equal to 22%. Okay, so the biggest thing is recognizing first that it is a decay because it is less than 1. And then you have to recognize that it's not just that 78. You had to take 1 away from it. So our choice 2 is going to be our final answer. Let's just look at one more just like that and then we'll be done. So the function V of t is equal to 1,350 times 1.017 to the t represents the value V of t in dollars of a comic book t years after its purchase. The yearly rate of appreciation, so that is letting us know, first of all, it's going up, of the comic book is, so they want us to find just the rate. So again, this represents 1 plus our rate. 1 plus our rate. So really, the 1 is not part of it. Our rate is that 0.017. Now, we had taken our rate and turned it into a decimal. So when we moved our decimal 2 units to the left to get it, we took the percentage and moved the decimal 2 units to the left. We have to move it back right 2 units, making it so that we have 1.7%, giving us choice 2.